Hi everyone. In this video, I am going to explain about the introduction of VHDL. So, introduction to VHDL. This is the main important topic for the starting of digital integrated circuit design and its applications. So, in the subject of digital integrated circuits, all the hardware components, whatever we have studied in the STLD, switching theory, logic design, in most of the universities that STLD comes in the second year, and this digital IC design DICD comes in the third year. So this DICD is the extension of STLD where all the components what you have studied in the STLD are going to be implemented using programming. That programming is VHDL. Okay. So what do you mean by VHDL? VHDL, as I said, it is nothing but a programming language. So VHDL stands for VHSIC VHDL stands for VHSIC HDL. VHSIC is nothing but very high speed, very high speed integrated circuit hardware description hardware description language. Okay, so VHSIC stands for very high speed integrated circuit and HDL stands for hardware description language. There are generally two different programming languages available for describing a hardware component in a programming language. One is Verilog, another one is VHDL. So the second one is Verilog HDL. Verilog HDL. So Verilog HDL is the advanced version of the programming language compared to VHDL. Okay, VHDL consists of a lot of small uh, entities and architectures, whereas Verilog consists of only modules. Verilog consists of only modules, and it consists of this particular VHDL consists of entity and architecture. Entity and architecture. Okay, so VHDL is the basic and first method of hardware description language, and the second method is Verilog HDL. So in this particular digital IC design subject, we are going to see the introduction of HDL and the implementation of a small digital circuits using VHDL language, and as well as we are going to study the Verilog HDL and the implementation of different logic components, logic circuits with Verilog HDL also. Okay, so first let us go through the VHDL language. So VHDL, as I mentioned, very high speed integrated circuit hardware description language. It is a hardware description language. What do you mean by HDL hardware description language? Suppose if I say AND gate is there. So AND gate, a two input AND gate, if you consider, this is the symbol for the two input AND gate. This two input AND gate gives AB and AB as output. A, B as inputs, and Y is equal to AND operation between these two inputs A and B. So here we are taking one hardware component, and this is the output expression, Boolean expression Y is equal to AB. Now we need to describe the behavior of this particular AND gate as a programming language. Like Y implies Y less than equal to nothing but here Y implies A and B. A and B. So this is the programming line to assign Y is equal to A and B. That means AND operation between A and B, between two input variables. Here the AND operation is defined by a predetermined operator. operator. So this operator is AND operator. The AND operator specifies the AND operation between these two variables. Variable 1 and variable 2. So this type of programming we are going to write in terms of program that describes the behavior of your any type of logical circuit. That's why it is hardware description language. Okay. So as I said, it consists of entity and as well as architecture. It consists of mainly, it consists of, the programming language consists of two parts. Two parts. Those two parts are, one is entity, 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 and the second one is architecture. Second one is architecture. So what we will see now. So entity is nothing but it is the place where we are defining the inputs and outputs. Entity is a place where we are defining the inputs and outputs. So along with most of the times we generally consider inputs and outputs. Along with the inputs and outputs, we also specify the generic variables. We also specify the generic variables. So entity, and coming to the architecture, in the architecture we write the relation between the inputs and outputs. That means the entire behavior of the logical circuit is described in the architecture part. Okay, now coming to the first entity declaration. Entity declaration. So entity declaration, what is the general syntax for the entity? What is the general syntax for the entity? What I said, entity is nothing but it is a place where we are giving the inputs and outputs, or we can say it gives the external view of your logical circuit. Suppose if I say AND operation, it is having two inputs A and B. I am not describing the behavior here. It is just a AND behavior. We are expecting the AND to design, and the output is Y. So this particular logic circuit has A, B as inputs and Y as output. So in entity, we are going to describe the inputs and outputs of this particular logic circuit. So entity describes the inputs and outputs. Inputs and output ports, we call them as ports. In this particular VHDL or Verilog, the input connections and output connections are said to be ports. So input ports and output ports. Entity describes the inputs and outputs of a logic module or circuit, and also provides external view and provides external view of component, external view of the component. Okay, so for any component it gives the external view, just what are the inputs and what is the output. That's it. It doesn't give specify any behavior of that particular logic circuit. Okay, now entity, we will see the syntax of this one. Syntax: entity name, entity name is entity name is generic declaration, port class, that means port declarations, all the inputs and output ports, port class, generic declaration, and we are also having entity declarative item, entity declarative items. All these three are as a part of this one, and then and entity name. end entity name. So see the first line. This is the syntax. See the first line. Entity name. Suppose if the particular AND gate name is something like um, gate 1, then entity gate 1 is. And one more thing, when you are giving the names, entity name should not be the name of any operator. Suppose most of the times what I observed is students are giving the name as and, as they are performing and operation, they are simply writing and is entity and is. It is no way it is valid, because and is an operator, so the name should not be any operator name. And if it is like and gate, then and underscore gate, then that type of name you can give, and underscore gate. And gate, suppose if you want to give and gate and space gate, is not valid. Okay, names should not contain spaces, name should not be an operator name, and name should not start with a number. Okay, all these are some conditions when you keep the name of entity or architecture. Okay, so entity name, and these are different generic declarations, port declarations, and entity declarative items, and then it is entity name. You should end with a semicolon. Now coming to the first one, where the generic declaration, where the generic declaration declares constants that can be used that can be used to control the structure or behavior, the structure or behavior of the entity, okay. Again, syntax for generic, so it is constant name generic, constant name name of the constant, subtype indication, and constant must be equated with a value colon equal to initial value, some value. Constant name, subtype indication, and again some initial value. Okay, so like this we will give close colon, semicolon. Now constant name is nothing but it specifies the name of any generic constant. Type specifies the data type of the constant, whether it is a integer or character or float, whatever it is. Okay, that type it is specified here, that is done by subtype. And initial value specifies the initial value of the constant, initial value. Okay, whether the number starts from 0 1 2 3. Suppose we are having a count value that starts from n, that starts from 0, so count n 0 to something like it has to increase up to 4, like that. Okay, syntax for generic. And coming to port class is very important and most commonly used. Generic may be optional, that depends upon the user requirement, but port is mandatory. Port, without port you cannot specify the inputs and outputs. So the port class specifies the interface channels the interface channels of the entity. Channels of the entity. And its syntax is syntax of port. So port, port, port name, port name, mode, subtype indication, and if you want to give value here only, otherwise just a semicolon, and it will be continued for how many number of inputs or outputs are there, that many will come. See here, port name, port name is nothing but, suppose in our example I told you one AND gate is there. Okay, so in this particular logic circuit, it is having two inputs AB and one output Y. Then it is represented as port. What is the port name here? A is the port name, colon, A is the port name, colon, mode. In which mode it is? There are three different modes: input mode, output mode, and input output mode. Three different modes: input mode, output mode, and input output mode. So in out mode. So here A is nothing but input mode. So you have to write it as in, IN. It is capital or small, you may have a doubt. Okay, VHDL programming is a case insensitive. VHDL programming is case insensitive. Even if you write small letters or capital letters, that doesn't change the behavior of your program. Both are accepted. Okay, in and subtype, it is uh, STD, standard logic. Standard logic or boolean or bit, all these are different subtypes. Okay, and similarly B is also an input. So B in STD logic, and Y is the output. So Y out STD logic. This is your port declaration. So port declaration, in this port particularly we will specify what are the inputs and what are the outputs. Okay, here just simply, instead of taking two lines for two inputs, just A comma B in STD logic, that is also fine. Okay, this is the declaration of the port. And coming to port class, after that we are having entity declarative items. Entity declarative items, see, the entity declarative item declares some constants. The entity declarative items declares some constants. Entity declarative items declares some constants, types, or signals that can be used in the implementation of the entity. In the implementation of the entity. And the entity statement, it is also having another part, entity statement port, that contains the concurrent statements which are used for checking the operation of the conditions of the design entity. Okay, suppose for example entity full adder. Just I am writing the entity for the full adder is. So the full adder specifies the name of this entity. Entity full adder is port of. So for full adder, three inputs are there: A, B, C in. So simply A comma B comma C in as input. STD logic. We can simply say STD logic or bit is also accepted, as I said earlier. And two outputs are there: sum and carry, sum and cout, as out bit. So to after two inputs are completed, don't give any semicolon. Close the bracket and then semicolon. Close the bracket and then semicolon is the only at the last line. Until then, if n number of lines are there, all the n number of lines should take semicolon. Only the last line will take the bracket and then semicolon. And entity name, and what is entity name in our case? Full adder. Don't give space, full adder. If you want to separate the words, just separate by a underscore, separated by using an underscore. Okay, so and full adder, semicolon, and don't give semicolon after is. Okay, so this is the entity declaration. This is the entity declaration of the code. Okay, in the next video I will explain about the architectural description and what are the various components involved in that. Okay, thank you.